All right. So again, density is going to be a measure of the compactness of your object. And I asked which of these two is more dense or more compact. And then you all said the one on the right. And you described it as the water because these are water molecules. I will remind you that both of these are water. And this is just a very non-dense. Do you guys remember what form of water this was?
Ice.
Ice, exactly. So this is that form of water that is actually, even though it's a solid, less dense. Yes, Dalton.
When we're finding the density, do we just divide by the coefficients, or do we actually do something with the cubed?
So yeah, you're not really gonna change the units if you're looking at the math. You're just gonna be messing with the coefficients. So you're exactly
Okay.
right. You're gonna take those two numbers and divide, and those units, they don't go away. They stay in your answer's unit. So your density ends up having those centimeters cubed and the grams. And when we get back to that slide, I think it's like two later, I'll point that out. So just actually, I think it's the next slide. Look at that. All right, you were probably on the next slide anyway. So right here, they just show up in your answer for density as the unit for density. And so one of the ways you will be able to recognize these, and one of the things that I really want you to stress is that I told you about the metric system and metric measurements so that you can remember which units represent which qualities. Now I will describe them as qualities or characteristics of matter, but there's certain characteristics or qualities that you should be able to recognize simply by looking at the unit given. So you should be able to recognize that grams is a measurement of mass, and that mass is a measurement of how many molecules are in that object or how much stuff it has. You should be able to see centimeters cubed now that we've discussed it, or milliliters, and recognize this as a volume measurement. And then remember that volume is a measurement of the amount of space that that object takes up. And then because these two are related for density, and the relationship is as follows, mass divided by volume, the answer or the units for density will always have either grams per centimeter cubed if you used a ruler for volume, or grams per milliliter if you used a displacement, which is where you used water displacement by dropping an object in water and seeing how much the level of the water rose. So if you ever see these units of grams per centimeter cubed or grams per milliliter, you should be able to recognize that that's mass over volume, which is by definition density. And if you ever see grams, you should be able to recognize mass. And if you see either of these two volume measurements, you should be able to recognize volume. That's one of the reasons that we immediately went into density after learning about the metric system, so that you could start seeing these units used in calculations and used in real life. So that's one of the points of this class, is to be able to recognize these variables and the units associated with them. So again, they kind of go through, it's going to be your mass divided by your volume. And so if you have the same amount of volume, if every object of different objects have the same volume, but each of them has a different mass, that's going to suggest that they have different densities. And so the larger the mass, if you hold the volume constant, so if they all have the same volume and you have larger masses, that object is going to be more dense. And so here in this case, iron is the most dense because you've got 8 grams that occupy 1 centimeter cubed. Okay. Now we're looking at the idea that every substance has its own density. I will remind you that this is how we identify unknown objects. So for instance, if we were to have a meteorite that struck the earth and just a tiny little itty bitty fragment was left over, and there was some metal in there and we weren't sure exactly what kind of metal it was, one of the things that scientists can do is they can pick that metal out and they can do really precise measurements. So they would measure its mass first, if you guys remember the process, and then they'd measure its volume. And so just those 2 bits of information would give them a density. They then look at a chart very similar to what you see to the right here, and they would determine, based on that density I saw, what is the closest thing here. All right, so maybe they found that it had a density of somewhere around 7.8 or 8. And so what that means is that they think it's some kind of iron. Now they can start looking and testing to see whether it's iron. And the reason you want to be able to do this, and it's an important reason, is because what if you have a tiny sample, right? There's lots of ways to identify iron, but they generally involve chemically reacting it with something. So iron reacts a certain way with certain things. And so if you put it in a container with those things, it will react. But sometimes it uses up that iron and turns it into something different. And if you don't want to do that with your sample, sometimes density measurements are a really good and non-destructive way to measure and determine what an unknown substance is. So the last thing to note on this slide here was that water has a density of 1 gram per centimeter cubed, or 1 gram per milliliter. And that means that if you've got water that isn't super salty, and that's why it says distilled water, it doesn't have extra stuff mixed in, then it's going to be 1 gram per centimeter cubed, or 1 gram per milliliter, which means that if you have a milliliter of water, you know that you have a gram of water. So however many milliliters of water you have that many grams. And then the reverse is also true. However many grams of water you have exactly that many milliliters, which is one of the reasons that we have that we use water, because it's a really good reference when we're talking about densities. So this talks about how if every object has different densities, what happens when those objects interact with each other, especially when they're fluids. All right, now I want you to understand that if you put a piece of wood and a piece of metal on top of each other, if the metal's sitting on top of the wood, it's not going to sink through the wood. I mean, it might press down on the wood, it might even bend the wood a little bit, and if it's a maybe balsa wood, it might break the wood, but it's not going to sink into the wood because they're solid. And I want to remind you that this statement that the more dense object will sink, that it will sink in a fluid. If you put it into a fluid, it is more dense than it will sink. And fluids even react this way with each other. This includes air. Air acts as a fluid, so any kind of a gas will also do this. All right, so if you know anything, just as a little side note, if you've ever heard anything about carbon monoxide, that's a gas that's more dense than air, and it sinks to the floor. All right, and so that's something to note there. All right, there's lots of different gases we're going to talk about, and you can see here that carbon monoxide is more dense than the air, but just barely. But carbon dioxide is also a little bit more dense. Alrighty, so the big idea there is that if you've got two fluids interacting, the heavier of the two, which means the more dense, is going to sink to the bottom, and the less dense object is going to sink to the top, and they will actually organize themselves by way of density if you put multiple fluids in there. Now I'm going to tell you, if you try to do something like this right here, you would want to add them one at a time, because if you tried to add the honey at the top, it would have to sink through all of these, then it would mix with them, and it would just kind of make it a lot less, very straight lines here. It would not be that way. So they poured these in one at a time, but the fact that they're not the same density is why they don't mix. So that's a really cool fact. All right, so different objects have different densities. We just kind of talked about that. And you can determine whether something is more or less dense than a fluid, particularly water, if you put that object in the fluid and you determine whether it sinks or floats. So the example we've got here is ice. And ice does what in water?
Floats.
It floats. All right, this is a lesson that everyone on the Titanic learned better than anyone else. Ice floats, all right, but it doesn't float all the way. So next time you've got ice cubes, you might have ice cubes in water with you right now, but at some point in the next week, you will have ice cubes in a drink. And I want you to look at how much of the ice cube is above the water and how much of the ice cube is below the water. All right, and so long as you don't have like so many ice cubes that you're like pushing it up and it's like a solid block of ice, you guys know what I'm talking about. So if you just had one or two, like what you see in this drink, you're going to find that the majority of that ice is actually below the water, which is what happened with the Titanic. It hit an iceberg in the middle of the night where it couldn't see very well. And the thing about icebergs is that the majority of them, 93% of them, is actually below the water. So that's a really cool fact, that because ice is 93% or 92%, depending on what kind of ice you've got, the density of water, that means that 92 to 93% of that ice is below the water, and the last 7 or 8% is above the water. So I want you to test that out when you get a chance. So maybe later today over lunch. All right, let me know if you find something different, because I'd be interested in that. I don't think you will. So objects with more than 1 gram of or gram per centimeter cube or gram per milliliter will sink in water. Again, I gave you the example of panning for gold there. All right, so did I show you guys the sulfur hexafluoride video?
No.
No. All right, if we have time, we'll watch that today. This is called deep voice gas or heavy gas. All right, so now we're going to get to the part that I really care about for this. I wanted to review all of that because you're going to see it again today in the quiz. But step one here of determining density is to find the mass of the object. All right, so you're going to find the mass. Again, that's a scale. Then you're going to determine the volume. There's two ways. You either measure it with a ruler, and that doesn't work for many things. If it is a perfect geometric shape, like a cube, cylinder, or sphere, then you can use like actual measurements with a ruler or a tape measure, and then use that formula that's given or that you can find on the internet. But if it's any object that it isn't regular, which means it's not perfectly a geometric shape, you're going to have to use water displacement. Water's non-compressible, which is a really neat fact that allows it to move up by exactly the volume of the object that you submerge in it. So next week, if we have some time, I'm going to fill you in on the guy who determined this. So the whole story of density actually goes back a few thousand years. Now, we've known what density was for a while, but there was a famous scientist that even has a famous saying associated with this that you have heard before, but you might not know where it came from. So I will share that story with you next week. It's actually a pretty cool story. It's a historical story. So again, when you submerge something in water, the water level rises by the exact amount of volume that that object occupies. So now this, as a reminder, you're going to calculate density by plugging mass over volume. So I want to go ahead and give you a warning that this is not the only thing that I could ask you to solve for. Anytime you have a 3-variable equation like this, so we're looking at density is equal to mass over volume, you have the possibility of solving for mass or solving for volume. And now I'm going to show you in just a little while. I'm going to switch screens. We're going to go to a Smart document. I'm going to draw out how to algebraically and graphically. I'm going to show you a graphic that's going to help remember how to solve for each of the 3 of these, and then we're going to practice one of each kind of problem. All right, so I want to remind you that on Wednesday we went through this. So first you find the mass of an object, then you find the volume of the object, and then you divide mass over volume in order to determine density. So it gave you 35 grams and 7 centimeters cubed. If we look here, this is how I would like you to set up any math problem. This is a really, really efficient method. It takes a little bit of extra time, but I'm going to tell you right now, up front, if it's easy, you might get into the habit of not doing this. And right now, this one was easy because it's a direct multiple of 5. But in the future, when we're dealing with multiple variables and kind of complex problems that are a little bit more difficult than this setup of writing what you know, writing the formula you're going to use, identifying what you don't know, and I'm going to show you how I do this because it's a little bit different than what they do. And then you're just going to take the equation that you wrote and you're going to plug the values that you know into that equation, and you're going to solve for that unknown that you identified, which is exactly the process that they take here. They divided 35 grams by 7 centimeters cubed, and as you see, we've got that density measurement of grams per centimeter cubed, and it is 5 because you're just going to divide those coefficients like Dalton pointed out earlier. Alrighty, so now I've got a question for you, and I want you to try this at home. So I want you to get your calculator out, and that might be your phone right now, but again, I'm going to encourage you to get an actual calculator. Worst case scenario, you can use the one on your computer. That's a TI-84. But I want you to try this problem. So osmium is a very dense metal. What is the density in grams per centimeter cubed if 50 grams of the metal occupies a volume of 2.22 centimeters cubed? So my first statement is you're going to follow that prompt from the last one. First, write down what you know. What did the problem give you? What do you know about this? All right, so it has 50 grams. What kind of measurement is that? So you're going to write that down. Is that mass or volume? And that occupies a volume of 2.22 centimeters cubed. So I write that down as well. Now, you've got your 2 values. What is your equation? What's the formula you're going to use? What is density equal to? Anybody?
Mass over volume.
Thank you, thank you. It is equal to mass over volume. So you've been given a mass and you've been given a volume. So you're going to divide those two numbers, and what number does that result in?
2.
Yeah, number 2. All right. So I don't know why they did 1, 2, 3 and not ABC. I don't like to number answers that have numbers in them, if that makes sense, because it gets confusing. But just to let you know, it is number 2 right here. All right. So it's this answer right here. So 22.5 grams per centimeter cubed. If you know anything about half of 50, it's 25. And this is just a little bit more than 2, so it should be just under 25. Now I want you to notice that they've got a or they've got something that's super close, right? It's the same number, but 1 decimal off. So always make sure that you check where your decimals are and that you type carefully into a calculator so that you don't accidentally, get 1 decimal point off and get the wrong one. I'll generally try not to have that too often, like you won't see that for your quiz today, but just be aware that that's always a possibility. So make sure you're accurate. All right, and the last practice problem here is another density problem. So you're going to practice actually calculating density. Now, this one's slightly different. So follow along with me and then ask a question if you have one. What is the density in grams per centimeter cubed of a 48 gram selection of metal if the metal raises the level of the water in a graduated cylinder from 25 milliliters to 33 milliliters? So before we try this, I want you to think really quickly. When I took those 4 balls and then dropped them in the water level rose from 650 milliliters to 750 milliliters. What was the total volume of those 4 balls when I dropped them in the water?
100 milliliters.
100 milliliters. Exactly. Good job. So if that's the case there, and you take the final value of 750 and you subtract that initial value of 650 to get 100, you're going to do the same process here. So what's our final volume here? What's the final volume of that graduated cylinder?
8 milliliters.
All right, so that's going to be the change. What's our final? What did the level end up at?
33.
33. And where did it start?
25.
25. All right, so you'd say 33 minus 25. And just like she stated earlier, that's going to be 8 milliliters. All right, so we've got 8 milliliters and we've got 48 grams. So what's our mass?
48 grams.
What's our volume?
8 milliliters.
And what's the formula for density?
Mass divided by volume.
Mass divided by volume. She's like, I know this. Come on, we got it. So mass divided by volume, 48 divided by 8 is equal to
6.
6. There we go. All right. Everybody had 6 like 2 minutes ago, and you're like, why are you dragging this out? I want to make sure you see the process because the process is way more important here than the product. All right. So that's 17 out of 17. You're like, we're done with density. Actually, I told you, I'm going to show you how to calculate mass and volume in the same way. So I'm just going to really quickly share my screen to a Smart document. So I want you guys to follow along. So far you have, let me try that again. So far you have this equation. Density is equal to mass over volume. All right. So algebraically, I can solve for either of these two values over here just by doing a couple quick tricks to move something away from the other one. So just to remind you, in algebra, if you want to solve for a variable, you're going to get rid of the other variables that are attached to it by doing the opposite procedure that keeps them attached to what you're solving for. So let me explain what that means. So let's say I want to solve for mass. All right. If I'm solving for mass, what is attached to mass in the original formula?
Volume?
It's going to be volume. And how is that volume attached? How are they related?
By dividing.
By dividing. All right. So if you divide there, what's the opposite of dividing?
Multiplication.
You're going to multiply both sides by volume in order to get rid of it here. Because you can't just make it disappear because it still exists. But you're going to multiply it onto the other side in order to get mass by itself. So if I multiply both sides by volume, it's going to give me that mass is equal to density times volume. All right. And so this is our new equation for mass. And now we're going to do the exact same thing from this formula. I want to solve for volume. I want to know what volume is. So what's attached to volume right now?
Mass.
Well, no, in the second equation.
Second. Oh, density.
Density. All right. How is density attached to volume?
Multiplication.
They are being multiplied. So what's the opposite of multiplication?
Division.
Density.
There we go. So the opposite of that multiplication is going to be division. And so I'm going to divide the whole thing by density. So these two densities cancel out. So that you're, and then the density comes over here, and you get that volume is equal to mass over what? Density. All right, so I'm going to write these three equations without any annotations. So density is equal to mass over volume. Mass is equal to density times volume, and volume is equal to mass over density. All right, so that's the algebra. I might have lost one of you or two of you or a couple of you with the algebra. If that's the case, guess what? In my back pocket, I've got a trick that will solve all of those confusions. So if you've had 8th grade, you had physical science in 8th grade, you probably are about to recognize something I'm going to do. And if you've never seen this, this is a lifesaver. All right, so this is a triangle, and this is your best friend in this class. So you will always, if you have a 3-variable equation, be able to make a triangle that tells you how to solve and get these equations without memorizing these 3 equations, okay? So density is equal to mass over volume. So mass over volume, mass over volume, okay? And then if we look here at this equation, volume is equal to mass over density, all right? Mass over density. And then if we look at this equation, mass is equal to density multiplied by volume, all right? So this right here is the way your triangle is going to be set up. Now, it doesn't matter where the 2 in the bottom go. You see that? So if I have them in either side, it doesn't matter. I like to start with density just because this is, called the density problem. It just matters that mass goes up top. If we look at our 3 equations, so right here, you're going to notice that mass only ever shows up in the numerator, right? It is never in the denominator. And so because of that, it shows up in the top of the triangle. It's the big dog. It's the massive guy at the top, all right? So mass is always going to go at the top of the triangle. And then if you notice in this top equation here, we've got volume in the denominator. So we've got volume down there. In the third equation, we've got density in the bottom. And so right here, density is in the bottom. And so let me show you how to use this triangle, because this triangle is mathematically showing you a couple things. So when I've got density and volume next to each other right here, I want you to look at this second equation. Mass is equal to density times volume. How do I know that this means times? They're right next to each other, okay? So when 2 things are right next to each other like that, that means multiplication. Let's look in the triangle. Which 2 are right next to each other?
D and V.
D and V. So that's how you're going to know that this actually means multiplication. All right? That means multiplication. Now, what happens if I write something over something else? What kind of math does that mean?
Division.
Division. And so that's exactly what we have here. We have division and division. So whenever you want to solve for something and you draw this triangle, all you have to do is cover up the variable that you're solving for. So let me show you. So I want you to just take your thumb, don't touch the screen, but cover up the D. So cover up density in the triangle, and what do you have left?
Mass over volume.
Mass over volume, and then look at that, that's your equation for it. All right, now cover up volume. So cover up the V, and what do you have left?
Mass over density.
Mass over density, and that is our equation for volume. Now let's do the last one and cover up mass, and what do you have left?
Density times volume.
Density times volume. This triangle will save your life in a pinch. So you need to write this down somewhere. So if you're taking notes in Kami, go ahead and write that somewhere real big in Kami. If you're taking notes on paper, write it real big somewhere on your density notes, because you will need this, and I'm going to immediately make you use it. So what I'm going to do is I'm going to erase everything over here, because that's just, it looks like garbage. All right. And I'm going to give you a practice problem right here. I'm going to keep these on the screen, okay? So I'm going to give you a practice problem, and I want you to try it. I will not have you solving density. I'm going to have you solve for mass and volume. All right, so remember these equations because you're going to use them here in just a minute. All righty, so we get out of here at 9:05, correct?
Yep. Yes.
All right, so are you guys looking at the, can you see the smart board?
Yep.
Okay, just making sure because it kicked me out for a second. So if you have a density of 5 grams per milliliter and a volume of 10 milliliters, what is your mass? All right, so I want you to try that out for me. So use your triangle if you need to, or if you can remember the equations, you can use those as well. So you're going to be solving for mass. And remember to give me a unit. All right, due to our limited time, I'm going to go ahead and ask, what's the answer?
50.
50 milliliters.
50? No, I'm asking for a mass. The milliliters cancel. We're left with 50 grams. All right, now let's do one where we solve for volume. All right, so I have a density of 12 grams per centimeter cubed. And I'm going to have a mass of 24 grams. What is my volume?
2.
So what was that?
2.
2 grams.
2 grams.
2.
per centimeter cube.
Not quite. So density is grams per centimeter cubed and mass is grams. So the grams cancel and what are you left with?
12 centimeters.
Centimeter cubed. So you should remember that this is a volume measurement. You will never have grams as an answer for volume. You'll never have grams per centimeter cubed as an answer for volume. You're either going to have milliliters or centimeters cubed. Do you guys have a question on how to calculate these? We good to go? All right. So what I'm going to do now, we're going to see, we've got all of 7 minutes. That is not enough time for me to give you this quiz. So you are quite literally saved by the bell. All right. So what I'm going to do instead, I'm going to go ahead and stop recording.